Everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be talking about Cramer's rule. Cramer's rule. And when you first look at this lesson, this is lesson 6.5 in your books. Lesson 6.5. It's on page number 300. Whoa, there's a milestone. We reached page 300. That's awesome, right? You guys been working hard this year. Good job reaching page number 300. When you look at this chapter, you're like, oh my goodness, what is going on here? Look at that picture of that old guy, and look at all these weird letters and numbers, and what is happening right here? Well, when you first look at it, you may be a little bit intimidated by the information. But here's the good news. The information is not that hard. Like once you kind of boil it all down and figure out what exactly they're talking about, you should be like, oh, okay, I can do that. In fact, by the end of the lesson, my guess is that you will think, I never want to do a substitution. I never want to do an elimination. I never want to do a Gaussian. I only ever want to do Cramer's rule. I mean, I love this. This is great. And so my guess is that that's how you will think about this by the time we're done with the lesson. Right now, you're not thinking that way because you're looking at all these little matrix-looking code things all over the place, and you're like, whoa, this is too much. But it's not. So let's take it piece by piece and find out how we can do this. Number one, let's look at the definition of Cramer's rule. What is Cramer's rule? This will help us to understand what to do. Divide the determinant of the target variable by the determinant of the coefficient. Okay, so what does that mean? What is the target variable? Well, for example, the target of x, you can look down here, the target of x is x. I don't know why it's not writing. There it goes. The target of x is x. Okay, so notice it says the target variable. So you take the target, so if we're looking for x, x is our target, then the x matrix, okay, and you'll see how that works in just a second, but the x matrix, that's what this is, remember the determinant matrix, is over or divided by the coefficient matrix. We're going to call that A. We could have called it C, we could have called it whatever, but we're going to call it A. That's what Cramer called it, so that's what we're going to call it. That is Cramer's rule. That's as simple as I can get it. So if you're looking for x, you take the x determinant matrix, the target matrix, and you put it over the coefficient matrix. Okay? We're going to learn what these things are in just a second. We're going to learn how to do that. And it's really not that bad, especially if you have the book to look at, and then that'll help you before you kind of get it memorized. So what is the target variable? That's the one that we're looking for, all right? So if we're looking for x, x is the target. What if we're looking for y? Well, y is the target, okay? That's what we're looking for. What if we have three variables? What if there's a z in there? Well, then z is the target variable. Whatever we're looking for, whichever one we're trying to find, that's the target, okay? So you put the target over the coefficient matrix. Target matrix over the coefficient matrix. Now, let's go into this a little bit deeper. How do you find, and if you want to, I mean, if you're really into math, if this is something that you just love figuring out, you can look at page 300 and it will show you how they developed, how they came up with the x target variable, okay? And so if you look at the first one, here's kind of the trick that you need to know. So let's not look at that right now. Let's look at this right now. And this is what you need to look at. So if you're looking on page 300, you're going to get lost if you don't understand this right here. This is our system of equations right there, okay? Notice, you know, this could be, let's just put a random system down. Let's put 3x plus 4y equals 6 and 7x plus 2y equals 5, okay? Now, I want you to see what they've done here. They've substituted a in for 3 and 7. Why? Well, because we're going to substitute these back in just a minute, okay? But they've done it right now so that they can show you what works for all of them, okay? So they're just using a variable right here. instead of actually showing you how to do it on one with numbers, they're showing you how to do it one if it had a variables. And this is going to be useful because these ones right here are always going to be A1 and 2. So this one's going to be A1 and this one's going to be A2. This one's going to be B1 and this one's going to be B2. This one's going to be C1 and this one will be C2. And so now when we get ready to solve this, now we're not going to substitute it in here. What we're going to do is we're going to substitute it into this. So everywhere that you see a C1, we're basically building a matrix right here. And so you're going to go find the C1. Well, what's the C1? Well, it was 6. So here you would write a 6 where that C is. That would get a 6. What's C2? That would be a 5 right there. What's the B1? That would be a 4. And what's the B2? That was a 2. And so this one would be a 2. And so you're refilling in this little matrix with the variables that are there. Now, let's go back to page 300. So if you want to understand how they got these, most of you, I'm just going to be honest with you, you don't really care. You just want to get the right answer, okay? So if you don't care, then don't look at page 300 right now, okay? If you do care, look at page 300. When you look at 300, you're going to see how they came up with, how did they develop the X. Now this should have marks out, there we go, because that's the determinant matrix. So how did they figure out the determinant matrix here? Well, it shows you what they did. It shows you the process that they went through. I'm not going to take you through that process, but basically the idea is they multiplied this one by B2 and this one by B1. Long story short, they basically did some algebra to it. They reduced some stuff. They figured out some things. They took away some things. And then, boom, they came up with that. Okay? And then, boom, they came up with that. And then they came up with that. Now, what are those? That's what we need to know. What are they? Okay, well, this is the X target. Remember, it's a target. We're targeting that X. We want to figure out that X. So in this little formula right here, this goes into that spot. And this A over here goes into that spot. Then we just divide it out. So we solve the matrix, and then we divide it out. You'll see how it works in just a second. It's not really that hard. Here's what you need to know. This page that's showing right here on my screen, that's what you need to know. That's the important stuff from this lesson. You don't have to know page 300 to get the right answer. If you want to learn page 300, if you want to see how it all works, great. If you don't, you can still get the right answer. Okay? So what you'll do is you'll come here, and you will just plug in to this formula right here. You plug into that formula, you solve it, boom, you're going to get the right answer. So let's get rid of this. I was just putting up random stuff right here. And let's go down and let's do the example on page 301. So turn the page over one, page 301. And I have the example written right down here. So here's our system. Our system is X, or we could write a 1 right there. That might help us if we remember that that's a 1. So we're doing example 6.5a. It's on page 300. So now what we want to do is we want to figure out our three matrices. I'll put it that way. That's proper English. Okay. I think math is importanter than English, so I'm not much of an English guy, but I do understand the value of English. So yeah, so matrices, there we go. So what we want to do is we want to figure out our A, X, and Y, okay, because we need all three of them. So let's just start off with the X. I'll put the X in yellow here, and the X matrix is going to, and I'll just use the determinant matrix, and well, you know what, I'll use matrix form, okay? And so what are we going to put there? Well, let's go look at what the book tells us. Well, I wrote it down, so you can just look here. C1, C2, B1, B2. So what's C1? -4. What's C2? -1. What's B1? 2. What's B2? 3. So now what we want to do is we want to evaluate this matrix. And let's write all three of the matrices first, and then we'll go back and evaluate them. Okay, that's what we learned in the last lesson, how to find the determinant. Okay, so we want to determine the determinant right here. So let's go to the next one. We'll put this one in blue. So this will be the y, and this is going to be, we can go back up here and check out this one too. This is A1, A2, C1, C2. A1 is 1, A2 is 4, C1, -4, C2, -1. And then we will have the A. One of the reasons why I was putting it into the determinant form is because we are going to find the determinant. The book doesn't do that. If you're looking at it, I kind of wish they did. That's why I didn't write it in the determinant form. But I would write it in the determinant form. I think that'll help you right there. It'll help you remember what you're doing. All right, so then the A for this one is what? Let's go back up here. The A is A1, A2, B1, B2. So A1 and A2, 1, 4, B1, B2, 2, 3. All right, now we have to remember, what do we do? Okay, we find the determinant. That's what we're looking for. That's what this means right here. That's what these little absolute value looking signs mean, is find the determinant. Well, let's talk about how do we find the determinant. All right, we find the determinant by doing what? Well, going this way and multiplying. -4 times 3 is -12 minus, and then we go this way, -2. Minus minus is going to actually give us plus. So if I have 12 plus 2, then I have 10. So my x number, my x determinant equals 10. Actually, -10. Sorry about that. That should be a -10. I don't like that. Let me erase that. -10. There we go. That's better. All right, so now let's do the y determinant. And so we're going to do this one, and we're going to get -1. Minus, go this way, and we're going to get -16. So negative, that's going to be a positive. So that's going to give us positive 15. 15. So that's the y. All right. And now we have to find the A. That's the last one. Do it here. And so we're going here, and we're getting 3. Going here, and we are getting, these ones are both positive, so this one's a little bit easier. Well, that's a subtract. And then we have an 8. So we have 3 minus 8, and that's going to give us -5. So the A determinant equals -5. So there's our 3 determinants. Okay, now this is where it gets really easy to solve this. Once you kind of get that determinant done, really in a way you're done. Now you just have to plug it into the last little formula. What's the last little formula? This right here. Okay, so what's our x value? The determinant of x over the determinant of A. So it's x, -10, over A, -5. And then you would just solve that out, and that's going to give us x equals, and that's going to be positive 2. So our x equals positive 2. Now we would come over here and we can do our y. And so our y was y, determinant of y over, well, I'll go back up there and show you. Determinant of y over determinant of A. So what was the y determinant? 15. So now we're going to have 15 over -5. Divide that out, and you get y equals, oh, I'll put it over, I'll put it up here. Y equals -3. Okay. So our determinant for the x is 2, positive 2. The determinant for the y is -3. In other words, once we solve this, that's our answer. How would we write this? Well, remember, what are we solving? Let's go back here. We're solving a system of equations. How did we write answers for systems of equations? In coordinate points. 2, comma, -3. That's your best answer right there. And that's the way to do it. All right. This video is already 15 minutes long, so I'm only going to do one example. I do want to show you one other thing, and that is on page 302. I'm not going to do this one because I think that you can understand this one. And here's what I'm going to show you. I'm just going to show you that when you're looking for the z, the x still equals determinant of x over determinant of a. The y still equals determinant of y over the determinant of a. And the z now equals the determinant of z, you guessed it, over the determinant of a. Okay. Now, one thing changes right here, and that is because we now have 3. All right. So what changes? The only new one that you need to do, all right, so this one changes now. Okay, I'm looking at this right here. This one now changes to include C3 and B3. But there's got to be more than that. You're like, but Mr. Steve, what's going on here? Well, what's going on here is that we're adding a whole nother letter, and so now we have A, B, C, and D. Okay, so now the C goes with the X. So let me go down here real quick, and I'm not going to take a lot of time with this. So now this is what the new equation looks like. A1X plus B1Y plus C1, look at where that C is now. It's with the X. It's not our constant anymore. Or excuse me, it's with the Z. Equals D1. A1, B1, C1, and now D1. Notice D is now the constant. And if you'll look at page number 302, I'm not going to take the time to write it out. This is how you do it with 3 variables. Now I'm going to promise you something. If you work this out with 3 variables, and I was working it out. So if you're using Cramer's rule, and I was using Gaussian, or if I was using elimination to solve this, you would beat me. You would get done faster than I would. I promise you that, okay? This is a faster way of doing it, and this is like a shortcut right here. On your test, it's going to ask you, it's going to tell you, use Cramer's rule to solve this, and I'm going to need to see your work. So make sure that you're doing it like Cramer's rule. But under normal circumstances, if they just say solve this system of equations, you could use any way that you want. You can use elimination. It's fine. You'll get the right answer. You can use Gaussian. That's fine. You'll get the right answer. Or you can use Cramer's. That's fine. You'll get the right answer. Cramer's is the fastest way that I'm going to show you. There are other methods and things that are out there, but this is the one that we want to show you, that the book shows you. So we'll use Cramer's rule most of the time because it's going to be easier once you kind of get it down. So you're on page 302, very important page, when you're doing 3 variables. That's the matrix that you're going to use. That's the X, that's the A, that's the Y, that's the Z. Okay, those are very important for you to understand. All right, and then you just do it, same thing as you did with the 2, but now you're doing 3. Don't forget your matrix is now going to have 3. And so remember, if it's like this, you actually have to rewrite these again so that you can get your diagonals in there. Okay, don't forget that you have to write this augmented part right here. Okay, if you don't remember that, go back to the chapter or go back to the video on finding determinants. And when we have 3 determinants, we have to write that augmented section in there. Okay, all right. Well, 19 minutes, that's not bad. I got it done in under 20 minutes. I'm proud of myself. Okay, are you proud of me? You should be proud of me. All right, we'll see you later. You have a good rest of your day. Bye-bye.